Hey mathematicians, how are you doing today? So far we've been talking about simplifying expressions with exponents. And so today's focus is going to be on zero and negative exponents. And so I want you to take a look at what we have here. We've got 2 to the fourth, 2 to the third, 2 to the second, 2 to the first, 2 to the 0, 2 to the negative 1, 2 to the negative 2. And when you look at that, 2 to the fourth is 16. And 2 to the third is 8, and 2 squared is 4. 2 to the first is 2. 2 to the 0, do you see the pattern of what's happening each time? We're dividing by 2. So if we take 2 divided by 2, we're going to get 1. And then 1 divided by 2 is going to be 1/2. And then divided by 2 again is going to be 1/4. And so when we talk about numbers to the 0 exponent, you're going to get a value of 1 all the time. No matter what it is, 2 to the 0 is always equal to 1. Anything to the 0 power always is going to be equal to 1. And it goes with looking at the pattern of numbers. We could have done this with 10 to the fourth, 10 to the third, 10 squared, 10 to the first, 10 to the 0. In every case, you're going to get that x to the 0. Any number to the 0 power is 1. Okay. So that's the 0 exponent property. Anything to the 0 power. When you look, we gave you a couple different examples. It's always going to be to 1. Now, the negative exponent property, this comes into play because, again, our whole focus is to simplify expressions, right? We want them in simplest form. This is something we've talked about throughout this year and for years since elementary. You want to simplify your fractions. You want to simplify your expression. You want to simplify your exponential expression. That's what we're working on. That means that you can only have positive exponents. So a simplified expression has only positive exponents. It only has positive exponents. So what we're going to talk about today is looking at how do we get those exponents to be positive, okay? So when we're looking at those, if you take a peek here, and this isn't really super scientific, it's just kind of working through it. If you have a negative exponent and you move it to the denominator, it makes the exponent positive. If you have a negative exponent in the denominator, if you move it to the numerator, it makes it positive. So if you switch the location within the fraction, it changes the exponent to positive. All right, so let's play around and have some practice with these. First of all, talking about the 0 exponent. In this particular problem, this is the base. Okay, 12m to the 8th, n to the 7th over 8m to the 5th, n to the 10th. That is the base of this expression. 0 is the exponent. Anything raised to the 0 power is equal to 1. So what we want you to be able to do is identify what the base is, because some of you might have spent time before you saw that 0 was the exponent, simplifying the 12 and the 8 and the m to the 8th, m to the 5th, and n to the 7th, n to the 10th, and you don't have to do that. If you know that 0 is the exponent, you can just say it's 1. When I look over at this one, all right, m to the 0, that's 1. And now I'm working with my n. So we go back with our divisibility rules. I've got 1, 2, 3, 4, 5 in the numerator. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in the denominator. And if I go through and I cancel those, I'm left with 7 in the denominator. So it's 1 over n to the 7th. If you are using our rules from last time, you took n to the 5 minus 12, which is n to the negative 7. And to make it positive, you move it to the denominator. To make an exponent positive, and I want to be very clear, we're talking exponents here. We're not talking the base, we're talking the exponent. To get the exponent positive, you move it to a different part of the fraction. Let's take a look at this next one. I see that 0 is my exponent. It doesn't matter what the rest of this is. It's going to be 1. I don't need to spend a lot of time trying to simplify what's in the grouping symbol because the exponent is 1. All right, here we go. X to the 0, that's 1. So now I'm going to be focused on my y's. I have 5 in the numerator, 3 in the denominator. Y to the second is going to be my answer because 5 minus 3 is 2. Or you could say the 3 in the denominator cancel out 3 in the numerator. All right, here we go. Now, here we have 2 negative exponents. To make the exponents positive, you move it to the other part of the fraction. So when I look at this, the y gets to stay because the y has a positive exponent. It gets to stay. The x to the negative 4 and the z to the negative 6, they need to switch. So I move x to the negative 4th to the denominator. It becomes x to the 4th. I move z to the negative 6 to the numerator. It becomes z to the 6th. This is the answer for my problem. It's in simplest form. Each base is only listed once. All of my exponents are positive. Let's take a look at this one. All right, when I look at it, we've got our numbers. We've got the p's. We've got the q's. And we have the r's. All right, so I'm going to take each piece of that and simplify it. I'm going to start with 75/15ths, okay? 15 goes into 15 once. 15 goes into 75 5 times. So there's my first part. Now I'm going to look at the p's. I have 3 in the numerator, 5 in the denominator. There are 2 more in the denominator. So to keep this positive, it's p squared in the denominator. When I look at the q's, I have q to the negative 5 in the numerator, q to the negative 4 in the denominator. So if I make them positive, I need to put them in the other part of the fraction. And then I can look at it and I've got, okay, 4 in the numerator, 5 in the denominator. That means 1 more is in the denominator. So q to the first in the denominator. And then for my r to the negative 8, to make that positive, I move it to the other part of the fraction, and it's a positive exponent. And it's a positive exponent. Okay. All right, let's take a look at another one. The b to the third, that gets to stay put. It has a positive exponent. We don't do anything with it. But my a to the negative 3 and c to the negative 5, that's not working where it's at. So to make the exponent positive, I move it to a different part of the equation, so the fraction. So c to the 5th, that's got to move on up. A to the negative 3rd, that becomes a to the 3rd in the denominator. C to the 5th, b to the 3rd over a to the 3rd. All right. Take a look at this one. Again, I'm going to break out my highlighters so I know what I'm working with. You pick what strategy works for you. This helps me figure out what I'm working with, so I keep myself focused on what we need to do. Okay. So starting with my numbers, 36 over 9. That's going to simplify to be 4. 9 into 9 once, 9 into 36 4 times. Now I'm going to look at the x's. We have x to the 5th in the numerator. I have 1x in the denominator. That tells me I have 4 more in the numerator, so x to the 4th up here. Y to the 8th. I've got 8 in the numerator, 2 in the denominator. I've got 6 more in the numerator, so y to the 6th stays up there. 8 minus 2 is 6. And now I'm going to look at the z's. 3 in the numerator, 6 in the denominator. So I have 3 more in the denominator, z to the 6th. Z to the 6th. There's my simplified answer. Okay. Let's try another one. Remember, you can pause the video as you're going through if it seems to be a little bit too much. I'm going to break out my highlighter again, make sure I know what I'm working with each of these. Here we go. All right. All right, 9 goes into here one time, 9 goes into here twice. So I've got -1/2. And then when I look at my ends, 6 in the numerator, 2 in the denominator, that leaves me 4 in the numerator. Now, a couple other ways that you could write this, or -(n⁴)/2. Any of those will work. Okay. Here's a new one that you maybe haven't seen before. When you have a negative exponent, but this is a negative exponent of a fraction. So this is a little bit different than what we talked about. So to make this exponent negative, I'm going to take this fraction and I'm going to flip it. I'm going to find its reciprocal. So it becomes 5/2 to the 5th power. And then this takes us back to what we were talking about with the division property of exponents. It'll be 5 to the 5th over 2 to the 5th. And there's my answer. 5 to the 5th over 2 to the 5th. All right. And that is actually it for today. Have a fantastic day. We'll chat soon. Bye.